Hey y'all, I'm Emerson Murphy-Hill, a research scientist at Google. I want to talk to you about our paper, What Improves Developer Productivity at Google, Code Quality. So before I tell you a little bit about the paper, a little bit of context here is a lot of the papers that we write, everybody in the audience, I'm sure, there's a lot of work that goes into those papers. Well, this paper is, one of those too, where a lot of work went into it, but it also has a trick. It's not just hard work. There's a method that we use that has a trick that other methods don't have. And before I tell you about the trick, let me tell you about the problem with the typical types of research that we do. So a common research technique for me and for my research group is we use surveys to try to understand developer sentiment, and sometimes we collect signals, quantitative signals from code bases about what developers are doing. So here's like a typical survey we might run where we survey a bunch of developers about, how productive are you feeling, and how high of code quality would you say is the code that you're working with, if we want to understand the relationship between productivity and code quality. And just for simplicity in this example, let's suppose there's only two developers that are an entire organization, Aruj and Rusla. And for the simple example, suppose these two people, you wouldn't run a survey obviously with two people, but let's say these two people are totally representative. And let's say you get the answers back. People have responded here, and what you've got Ruse says they're somewhat productive, and the code quality kind of medium. And Rusla says, well, I'm extremely productive, and I have extremely high code quality. So that's good. So yeah, that suggests there's some relationship between productivity and code quality, a correlation at least. But when you think about this, these sort of cross-sectional surveys or data that you get, they're pretty limited, right? And For example, one of the limitations here is we don't really know whether it's code quality that's affecting productivity. It could be some third variable. So, for example, suppose that Aruj went to a really poor software engineering school, and that school is really responsible for them not having good code quality and not having good productivity. Say, for example, they went to Blackbeard's school for high C pirating and low quality software engineering, whereas Rusla, on the other hand, boy, they went to a great software engineering school, say North Carolina State University. We don't really know whether it was the university that these folks went to or whether one of these factors was affecting the other. It's just, you just can't tell from cross-sectional data. Now, let me show you what you can do a little bit better. The trick for this paper is what we call panel data, and it allows for better causal inference because you can factor out, you can eliminate some of those other potential confounding factors. Suppose that we have that first survey. So this first table is exactly the same as what we saw on the prior slide. So let's suppose 3 months later, we run exactly the same survey with Aruj and Rusla, and we find that their answers are a little bit different. So now Aruja's productivity has gone from somewhat to highly productive, and their code quality has gone from medium to high, whereas Rusla, right, went from extremely productive to somewhat productive, so her productivity went down, and went from extremely high quality to just high quality. So the quality went down too. So here's where we look at essentially the differences between the answers, not just the answers themselves. So what we find is essentially uh, Aruj got more productive, Rusla got less productive, and Aruj quality went up and Rusla's quality went down. So when you look at this, you see that the evidence is even a little better, right? It's sort of telling us the same story, that there is a causal relationship between productivity and code quality based on the differences between the answers that people gave. And the trick here is that I told you that the schools might be responsible. That is no longer the case. We can't actually say, we know that we can eliminate a third causal factor from this productivity relationship because that causal factor, if it's what we call a time invariant factor, a factor that would affect both time periods, if it affected both time periods, right, we would have seen it it would have been reflected in the differences, and it would have been a uniform. Essentially, it would have been a neutral difference. So we can eliminate these time invariant factors, like perhaps one person just went to a great software engineering school. Okay, so there's your introduction to panel data analysis. And so what we did for this paper is we studied productivity and a bunch of things that we thought might drive productivity. For example, for productivity specifically, we have a survey that's called NSAT. We run it every quarter, and we ask overall in the past 3 months, how productive have you felt at Google/Alphabet? Um, and engineers' responses to this question are you can predict actually with high accuracy using 6 quantitative signals. So, for example, if you look at the number of lines of code these folks write, and the other signals, you can actually predict people's self-rated productivity. So that's just sort of just to give you some confidence that like it's not just self-rated productivity. It's not just how people feel. That actually correlates pretty well with like quantitative productivity signals. So, um, so that's our productivity signal that we use, and then we sort of throw together like 42 different potential causes of productivity. So we divide them up into 6 categories. So one category is what we call goals and priorities. So that one question we asked about goals and priorities is a question again on NSAT, which is how much have shifting priorities hindered your team's productivity, right? And the theory is that like if your goals are shifting, productivity is going to be low, right? Totally reasonable theory. We had 18 questions on infrastructure, tools, and support. So, for example, this is a quantitative measure that we used here. We used how long your build times were. Everybody uses the same build system at Google, basically, and we looked at the 90th percentile. So, like your longest builds, did they take a long time? Well, that would sort of suggest that perhaps you'd have low productivity. But let's find out. And then we asked 3 questions about interruptions. So this is another quantitative thing. We looked at the 50th percentile of total time spent on an engineer's incoming meetings. We asked 10 questions about team communication, 5 questions about organizational and process factors, and 5 questions about code quality and technical debt. And then we run, as I said, InShot is a survey that we run quarterly, and we took 6 quarters of data, so a year and a half. And because right panel analysis is about differences essentially between subsequent data collection periods, that sort of yields 3 panels. And that's in the end, when you look at who filled out each pair of surveys, that ends up as about 2,100 engineers. So good sized data set for filling out this survey. Okay, and here's what the results look like. So one way we would present this is sort of in this quadrant chart where the x-axis is the effect size. So bigger effects are on the right, smaller effects are on the left. It's an absolute effect size, and then the vertical here represents the significance in terms of p-values. Just a little unusual, but I think the way to think about smaller p-values on the top and lower p-values on the bottom. I think the way to think about this is the things at the top were more consistent, sort of less standard error, less variance, and more variance at the bottom. So the things at the right, those are the things that are sort of like the strongest effects in this study. And what you see at the very top right there is code quality. That's the one that popped. That's the one that showed a high amount of significance and high effect size. That is, people who showed an increase in productivity also tended to show an increase in code quality. And likewise, if they showed a decrease in code quality, they showed a decrease in productivity. Now, there's one challenge with the interpretation of these results, and that even with panel analysis, you've got this problem of what they call reverse causality, which is we don't really know whether productivity is affecting code quality or code quality is affecting productivity. And both of those are like plausible theoretical links, but we wanted to sort of test them and tease them apart um, empirically. And so what we did is we posed a hypothesis that productivity affects quality on the left, and then another hypothesis that quality affects productivity. And then we took our panel analysis and we sort of shifted it in what we call a lagged panel analysis, where if you see On the left, you see a period of increased quality is followed by a period of increased productivity. All right, that would support the productivity affects quality hypothesis. Versus the other way, right, where you see if you see an increased period of quality followed by an increase in productivity, that would suggest that quality affects productivity, and vice versa. And when you run the numbers, it turns out there's much better support for quality affecting productivity than vice versa. So 3 out of our 5 measures confirmed that causal direction, and none of the measures confirm the causal direction in reverse causality. So, in conclusion, we've got quite strong causal evidence that improving code quality results in improved developer productivity. So, get out there, y'all, and if you want better productivity and increase your code quality, a lesson takeaway is like panel analysis is really cool. You don't have to do it with surveys necessarily, right? We did it with some quantitative data, so you can do it with GitHub data, for instance. Not entirely perfect. I showed you how we ruled out one potential confounding factor, but the panel analysis, for instance, is not robust to time variant effects. So in the example, if Rusla started taking a class between the first time we surveyed them and the second time, we would still not know that that might be responsible for the results. Thanks very much.